So why we need that distance over there is because we are trying to determine the radius of the circle. So what I'm drawing now, right? This is the radius of the circle. Right? This is the radius of the circle. Okay. So we know this distance is 20. And 20 for, we know this distance is 60. Right? So we now can calculate our radius of the circle. Right? So we can calculate our tau max, which is the radius of the circle. So this will be equal to 20. So 60 squared plus by 20 squared. So this is equal to 60 squared. So it's equal to 63.245 or 246 megapascal. Okay. So from here you can now construct your circle, okay? Or we can do another thing before we construct our circle. We can also calculate the principal stress. Which is your stress 1 and 2. Okay. Sometimes they label it A and B. Okay, you can label it 1 or 2, is up to you. Okay. So this will be equal to minus 20, the center of circle, plus or minus the radius, which is 63.246. So at one side is negative 83.246. Okay, so that is 1 point. And then at the other point, it is 43.246. So now if I were to draw, okay, if I were to draw a Mohr circle, we know that the radius is 63. Okay, so I'm drawing this digitally. It's more difficult, but if you have a compass, it's so easy, right? So I'm going to start with my circle. We know that the tau max is 63.246. So this is just eyeballing, okay? 63. And then the normal stress is minus 83. And then positive by 43. Again, this is by eyeballing, okay? 43. Wait, this is 50, this is 43. This is 70. Right. I was giving it too much. One is this don't look like 63. It's a bit big. So I'm gonna squeeze it in. And I'll try to move this down. And we're good to go. Okay. Right. So this is your Mohr circle now. Okay, your 2D Mohr circle. And this circle, so when you label this, we will label this as this circle belongs to the XY plane. And the XY plane is the in plane. Okay. the in plane, because it has a bigger surface area. The other one I did not draw. The surface area is not as big. Right. So from here, we are going to, so what we have done already is we are more than halfway there. So next, we are going to determine our principal plane. Okay, so next we're going to determine our principal plane. And we're going to determine, oh, before I do that, I do apologize. Over here, this is your stress 1. And over here, this is your stress 2. Okay, you can flip the name around, does not matter. Okay, but your principal stress are your stress 1 and your stress 2. Okay, so that's your principal stress. So next we want to find this angle. So from point X to this angle over here is our 2 theta P. Okay, our 2 theta P. Now, why is it 2 theta P? Okay, why is it 2 theta P and not just theta P? Okay, so I want to show you this now. Okay, let's look at the element first. Okay, from the element, so this is what we call our element. On the element, from point X to point Y, right, this rotation is theta. Okay, so we know it's a square, it's 90 degrees. Okay, so the element is the real world. Okay, the element is the real world. Mohr circle is the analysis part. So from point X to point Y, the rotation relative to the center of the circle is 180 degrees, or we call it what? 2 theta. Right? On the left hand side, on the element, is theta. On the right hand side, on Mohr circle, we call it 2 theta, because point X to point Y on Mohr circle is 180 degrees. And it's controlled by the stress. Okay. So that is why over here we calculate 2 theta P. Okay. Why? Later on we have to relate theta P to the real world. Right? Because in the real world, people ask you, so where's the principal plane? How many degrees do you know? Okay, so we have to answer that. Yes, we know, and we'll tell them the angle. Okay. So now to find tangent, to find the principal plane, and the formula is very straightforward. Right? So principal, we're going to find the principal plane. So the principal plane is where the shear stress is equal to what? 0. You can rotate from point X or you can rotate from point Y to theta P. The values will be the same. Okay, so tangent to theta P is equal to 20 divided by 60. Okay, so 2 theta P is equal to 20 divided by 60, 18.4 degrees. And it's going in a anti-clockwise direction. Right? Why anti-clockwise direction? So from point X, right? So from point X, right? This point over here, to get to stress 2, you have to rotate what? Anti-clockwise. Okay. So theta P is equal to 18.4 divided by 2, which is 9.2 degrees. Okay. So we have found the average stress. We have found the radius of the circle. We have identified our principal stresses. And we have found our principal plane. Okay. So the last thing that we're going to do, right? The last thing that we're going to do from here is draw and label the elements at its principal plane. Okay. Right. So now we are going to draw. Okay. We're going to construct our element. So I'm taking up my compass protractor now, and I'm measuring it, and indeed it is 18 degrees spot on. Okay, it's 18 degrees spot on. Okay, so now we are going to tilt the element by 19.2 degrees. Okay, so first of all, we are going to draw and label the element now. So now I'm going to draw the original X and Y. Okay, so this is our X, and then this is our Y. Okay, so this is our X, and this is our Y. Y not P. So we are told to rotate by 19.2 degrees anti-clockwise. Okay, so I'm going to now draw 19.2 degrees, or 9.2, sorry, not 19.2, 9.2 degrees. So this is about 9.2. Okay, so I'm going to and then I'm going to rotate this by 90 degrees. This straight line is the principal plane. At this straight line is the this straight line that I just drew is the principal plane. And it's going anti-clockwise by 9.2 degrees. Okay. So at this 9.2 degrees now, Lee, you have a question.
Yeah, can you re-explain why the angle in Mohr circle is 2 theta p?
Yeah, because on the element, right, you can see the element now. From point X to point Y, the angle is what? Theta, which is 90 degrees. On Mohr circle, point X to point Y is how many degrees?
180.
And 180. That is why it's 2 theta p. And then later on you put theta p, because theta p is the real world. What's happening in the real world? Okay?
But why you times p?
Theta p. 2 theta p. What do you mean times p?
Because I understand like why it is 2 theta, but I don't get where's the p
Theta
comes
p is the
from.
principal plane. Theta p is the principal plane.
Okay, yeah, makes sense.
It's just a label, okay? Subscript p is a principal plane, okay?
Okay, yeah.
Right. So now I'm going to draw our element. Okay, so this is our element. Well, relative, now we change our reference, and now it's going to be at the 90. Okay, it's going to be on the principal plane. Okay, so this is the principal plane orientation. Hey, it always does that. Okay, so this is the principal plane orientation. Oi. Okay. So now, on this principal plane or orientation, right, you're going to draw a vertical line. Okay, you draw a vertical line at this edge, right? And this is your point X on Mohr circle, right? And this will be point Y on Mohr circle. Okay. Why do I do that? So I can identify their magnitude. Okay. So from point X, right? From point X, right, which is over here, you rotate anti-clockwise by 18.4 degrees. You get stress 2. And stress 2 is positive, is 43.246. So when there's a case, right, over here, this angle on Mohr circle is what? 9.2, yes? Right. So when there's a case, right, over here is a tensile stress. Okay, over here is a tensile stress, and this value is 43.246 megapascal. And the other one from point Y, right, to stress 1, point Y to stress 1, the road is a clockwise, anti-clockwise rotation by 9.2 degrees. And we know that this will go into compression, and it's at 83.246 megapascal. And you realize there's no shear, right? Because at the principal plane, right, shear is equal to what? 0. Okay. So this exercise is very important. Why? Because what we have just done, okay,